Hi, I'm Haojian. I'm going to present our paper, Exploring the Needs of Users for Supporting Privacy Protective Behaviors in Smart Homes. This project is collaborated with Boyuan, Richard, Yaxing, Swarun, Yuvraj, and Yaxing. The initial idea of this project is a trick I found when I visited a few friends' home. I found that he connected his indoor security camera to a smart plug. He then set up a power schedule on the smart plug to ensure that the security camera isn't monitoring when it shouldn't be. It is a neat solution to protect privacy. So I searched online and wonder if others also do something similar. Indeed, many users are improvising tricks to protect their privacy. This paper refers to these tricks as privacy protective behaviors in smart homes. We also call them SHPBB. We aim to understand users' existing practices today and explore potential opportunities to better support the users' behaviors in the future products. We conducted 2 online surveys. The first survey posed open-ended questions to 159 smart home users, asking them to share their privacy protective behaviors, such as what are the tricks, when and why do they use the tricks, and what type of support do they wish to have. We then summarized the users' specific privacy needs based on the specific surveys responses, based on the first survey's responses, and derived storyboards about privacy protection concepts. This figure is an example storyboard. Each storyboard contains 4 to 5 frames covering the context, problem, privacy protection concept, and the user's reactions. At the end, we concluded with 11 promising smart home privacy protection concepts. We derived these concepts across 2 principal dimensions: life cycle and proactivity. By life cycle, we mean when users perform smart home smart home privacy protective behaviors, such as install time, routing, and when something goes wrong. By proactivity, we mean how clever the system is and how much effort required from the users. Our second survey then asked another group of participants to critique and rank 3 randomly selected privacy protection concepts. We have a total of 227 participants in the second survey. We found that more than half of our participants actively perform privacy protective behaviors. We identified 33 unique privacy protective behaviors in the paper, and the majority of them rely on ad hoc physical protections, such as powering off, blocking, and dodging cameras. Finally, most privacy protective behaviors aim to protect participants and their families. Most participants care less about their users, about other users, such as guests and people who are walking on the street. Remember that we asked each participant to rank these 3 storyboards in the second survey. We then used the Placket-Luce method to merge this partial ranking into a global order of all 11 concepts. The idea of Placket-Luce method is a probability model that can predict the outcome of a paired comparison, similar to how the rating system ranks chess players. Privacy diagnostics was the most favored storyboard. The idea of privacy diagnostics is similar to the security diagnostics in antivirus softwares. It is a mobile app that can assess the smart home configurations across all the smart home devices and offer step-by-step instructions on how to improve the privacy score. The figure illustrates the probability distributions that a storyboard wins over another. If we compare privacy diagnostics with the least favored storyboard called Anthropomorphism icons, the model shows that a participant has an 85% chance to prefer privacy diagnostics. We then analyzed the qualitative responses from the second survey to identify the factors that most strongly influence the preference of a concept. I will use a few examples to illustrate these factors. Privacy presets is one of the top privacy protection concepts. The idea is allowing users to switch between pre-configured global privacy modes, such as party, business, just me, and the system will accordingly update the privacy settings across all the individual devices. For example, if I have a few friends visiting me, I can simply toggle the party mode, and then all the cameras will turn off for a few hours. Many participants preferred this idea to other solutions because it has a simple mental model and it can offer meaningful privacy controls. In contrast, anthropomorphism icons is the least preferred feature. The idea here is to visualize device data collection capabilities in the look of a robot avatar. For example, if it is just a camera, it will be a robot with eyes. But if it's a microphone, it will be a robot with ears. Participants generally like the idea, but commented that it does not do anything meaningful compared to other features. Another negative example is the privacy chatbot. The idea here is the chatbot continuously monitor outgoing network traffic and allows users to ask privacy relevant questions through the chatbot. For example, when you see a suspicious advertisement, you can ask the chatbot if any devices have leaked relevant data outside. Participants do not like this idea because it does not prevent the problem from happening and requires manual interactions. Participants do not feel that they would have the energy to do so. In summary, this paper studied people's smart home privacy protective behaviors. We conducted 2 online surveys to understand existing practices and explore potential opportunities to better support users' needs. We found that users actively perform privacy protection behaviors in smart homes. We identified 33 unique privacy protective behaviors and found that most of them leverage physical control. We also found a promising privacy protection concept called privacy diagnostics. We identified 4 important factors in designing future privacy features, as users prefer simple, proactive, preventative solutions that can offer more control.